Hello everyone and welcome back to Kanai's A Lab. Today we are diving into a powerful technique that business use, grouping the products and uncovering hidden patterns. It's called product segmentation and we are using kmeans clustering algorithm to implement the same. Let's make it simple and practical. Before we jump into the algorithm, let us understand the concept first. Market segmentation or product segmentation. Segmentation is all about dividing data into similar, meaningful groups based upon similarities. For example, grouping the product by price, sales, or ratings. So, what is unsupervised learning? Kmeans falls under this category. There is no pre-existing labels like supervised learning. There is no prediction or there is no regression. The model discover pattern on its own. Clustering. This is what the magic happens. Data points with similar characteristics are grouped into clusters, like finding product groups that share common behavior. Kmeans algorithm is one of the fastest and most efficient clustering technique. It partitions data into K clusters, where K is the number of groups you want to form. There are a lot of real world use cases like customer segmentation, product categorization, market analysis, and even inventory planning. It's widely used to make smarter marketing and pricing decisions. So we have a sample data set which is consists of product information. We have information about 100 products and we have the information like price, rating, category score, sales volume, discount, stock availability, etc. So let us start implementing the k-means algorithm by using Python with IDE of Jupyter Notebook. Let us recap the problem statement. So we are going to identify the product group which support better marketing, pricing, inventory, and decisions. So we are going to use the data set to classify or partition the group into the division of clusters. So we have the problem statement from the product data and we are going to import the basic library needs. So we are handling with pandas for data handling. We need k-means for clustering and we need matplot for data visualization. Let me execute this. After that, we are going to import the data. So my data is in my admin download folder, which names as product.csv, which I am going to read using the read underscore csv function of pandas data frame. And I'm going to call it as a data frame name called data and reading the first 5 rows of the data. Let me execute this. So this is our data. Now we are moving to preparing the data and assuming in the beginning itself we need 3 clusters. Without revealing any information inside it, I am defining with a 3 clusters program. This X corresponds to data which excluding the stock availability which is in the string format. We are not handling those. Maybe you can do it in the later stage by converting into the encoding columns. I am selecting the numerical columns and we are defining with start off with 3 clusters and train the model use fit underscore predict function. You can see that fit underscore predict function is to train the model which returns the cluster assignment for each product. Let me execute one by one. So data for X, then calling the algorithm k-means with defining the number of clusters equal to 3 and this is called a method argument k-means plus plus and we are retaining the data which stores the same data for every training means that I need to store the data and data of cluster. I'm going to create a new column of cluster, which is the output of k-means.fit underscore predict, which is the prediction function. Let me produce the output. You can see in the output column, the particular column number last cluster is created the new clusters from the existing data. The new cluster numbers are added as the column cluster to the data frame, which help us to see which products were grouped together. Now we are going to visualize the same thing using the matplotlib. So basically, we are going to use the scatter function and defining what is your X, what is your Y, and defining what is the title and the alias of PLT, which is for the matplotlib. We are giving as a PLT alias. So let me visualize this particular visualize this k-means clustering with a cluster of 3. You can see the entire data is clustered into 3 different colors. With the color grouping, we can easily identify which data points actually covered into different groups. As we mentioned in the beginning, we defined a pre-defined category of how many number of clusters. Maybe for a simple data, or if you're known to your business very well, then you can give the numbers of 3. But sometimes if the data set is very huge or the data set contains unavailable information, you might not be able to define the numbers of 3. Then we will be utilizing the function of optimal number of clusters. So the optimal number of clusters for k-means is determined by identifying the number of clusters, which means optimal number of clusters using a chart called k-elbow chart. So k-elbow chart, which defines what is the sum of squares within the cluster against the number of clusters. So I will be showing the data. So this is the particular function. I am defining what is my inertia at the beginning. I am going to give assigning the range of clusters from 1 to 11. And with a for loop, I'm going to iterate each and every k-means what is the clusters 1, 2, 3, 4, 5, etc. up to 11. So each and every time this cluster is running with the initialization of k-means plus plus, defining the data, and especially we are predicting, means basically running the training with fit function, and I'm going to append the value of whatever it is happened that is within the cluster, what is the sum of square. So each and everything is plotting into a bar plot or into a line chart with column k range as an x-axis and y-axis inertia. As you can see here, for the cluster number 1, definitely the within the cluster sum of squares will be maximum. When the number of clusters increases, we can say that inertia is going to decrease, or within cluster sum of squares is going to reduce. So how do we define what is my optimal k? The points where the rate of decrease in inertia, you can see here, the rate of decrease in inertia decreases. You can say that decreases or starts to diminish. That indicating that adding more clusters provides little additional benefit. So we are going to take either 4 in this case, or you can take 3 in this case. So this called elbow point, where the inertia starts to diminish, or the clusters, when you are increasing the clusters of 6 or 7 to 8, which doesn't give any additional benefit. Within this particular chart, we concluded either you can take 3 or 4. Again, that's a business call. Assuming that I'm going to take number of clusters is equal to 4 and rerunning the same procedure, whatever in the previous steps, defining the clusters and running the k-means with the k-means initialization of k-means plus plus, using the same data for every training process, and fit underscore predict for defining and making a new column for clusters and generating data with new clusters. As you can see here, so we have generated new column for cluster with additional clusters value ranging from 0, 1, 2, 3. We are just plotting the final one with the final cluster details, executing here with the clear indication of number. We just rebuild the model with optimal k, with optimal cluster count of 4, and when retrain the model with and update the cluster assignment, we plot the clusters here. Now adding cluster number to each product point of analysis. You can see here each and every data point is aggregated into different clusters. So with that, we concluding with the implementation of clusters. Basically, k-means clustering algorithm for segmenting the product. As a summary, we can see that each clusters depends, or each clusters represents a distinct product group, which helping business to tailor the strategies like pricing, promotion, or stock planning to each segmented clusters. By using the k-means clustering, we successfully group the products into similar distinct segments based upon multiple attributes without giving any prior labels. That is very important. This is an unsupervised problem. This segmentation helps business personalized marketing, optimize pricing, and manage stock more effectively, targeting each group with tailored strategies. With that, we are concluding this video on product segmentation using k-means clustering. Thank you so much for following along. I hope this breakdown helps you to confidently tackle product segmentation using unsupervised learning. Stay tuned with Kanai's ALR for more AI content. Thank you once again for watching the video.